Hi, in this video we will learn how to write equations for lines in R3. You will see similarities between these equations and equations of lines in R2, but there are definitely differences as well. Okay, so to write an equation for lines in R3, we have two approaches again. One is using direction vector. Well, when it comes to the direction vector, the idea of a direction vector for lines in R2 and R3 is exactly the same thing. So you have a vector D, and then you find all the multiples of this guy that will make a line which is parallel to the vector D. But to fix a line, we need also a point. So if you fix a point P on the line and you fix a direction vector, so the line which passes through that point and parallel to the vector D, you will see that for each point x on the line, you can form the vector px, and px and d are parallel. So d and px are parallel. It means what? It means that we can find a number such that when you multiply to d, you get px for some scalar t. Well, we call this guy parameter, but px you can write it in form of difference of two vectors, the position vector x and the position vector p, and we'll take p to the other side or add both sides by p. This is p plus td. Well, this is exactly the form we had for the lines in R2, so it's called a vector form. The vector form of a line which passes through a point P and is parallel to vector D is given by this equation. So let me put this in the box and then we start an example. The example is find a vector form equation for the line through the points P, which is 1, 0, and 2, and Q, which is 0, 3, 1. So when you have two points on the line given PQ, you can use these two and form the vector PQ, and that is a vector which is parallel to the line. So we can take that as our direction vector, and that is Q minus P, which in this case is Q031. Lowercase q is the position vector of capital Q point, minus P is 1, 0, 2, which gives us -1, 3, and a -1. When you have that, use the P, so x, let let me write it like this first, plus TD. This gives us X, Y, Z equals to P102 plus TD. D is -1, 3, -1. And that's the vector form. Well, we can go a little bit further and expand this thing as we did before. So X, Y, Z equals to 1 minus T, 0 plus 3T, and 2 minus T. And then two vectors are equal. That means that we can write all equations for the components. So corresponding components must be equal, and those give us a set of equations called parametric equations for the line. So this is parametric equation, which is of the form we have three equations which are equal to first component, the corresponding component of the point, plus T times corresponding component of the direction vector. So that is the equation, parametric equations for the given line. Well, that gives us the options we have for the lines using the a parallel vector or direction vector. Now, how about normal vector? So that is using normal vector. So here there is something that you have to see, and that is, we already saw that if I fix only one normal vector n, all the vectors which are orthogonal to this vector, these are going to form a plane, not a line. But if I have another normal also, I can form two planes given by these normal vectors. So no, it was almost there. Okay. So if I have two normal vectors, n1 and n2, then the points which are in the intersection of these two planes will form a line, and that is how we can define a line using two normal vectors. So to describe the an equation for a line using normal vectors, we need two planes forming those ones, and two planes formed by those normals and the intersection of those ones. So let me just write it here. I have n1 and I have n2, and we have a point P here. Then the line which is orthogonal to both of these guys and passing through D is going to be the line we are going to define. And to describe this thing, we have actually what is called normal form. What normal form is nothing but two planes, equations of two planes together. So this is called normal plane, a normal form of the equation, which is, well, I pick n1 and p and generate normal equation for that plane. So n1 dot x equals to n1 dot p. I also take n2 and p and use them to generate the second plane. So n2 dot x equals to n2 dot p. Now we consider these two equations together, and that gives us the normal form of this line. So let me just put this. So two normals, and that's how we have it. Okay, so that is that one. And well, let's just do one example here. Example is find normal form, a normal form equation for the line through the point 102 and normal, and has normal vectors in 1, which is 1 2 0, and in 2, which is 1 negative 1 3 and 1. Well, we can form this easily. It is just the way it is written. So we will write two equations. N1 times x equals to n1 times p1. This gives us what? This gives us 120 dot xyz. This is equal to 120 dot 102p. n2 dot x also is equal to n2 dot p2, also gives us another equation, that is 120, oh, not 120, I already used 120. So this is the other normal, which is negative 131 dot xyz equals to negative 131 dot the same point. And these equations together gives us a line. So that's called a normal form for the line in R3. And well, we can, again, like the ones we did, we can expand those sides of these guys and write for each plane, write the general form of these equations. So we get x plus 2y equals to 1, and the other one is negative x plus 3y plus z is equal to negative 1 plus 2, which is 1. This is also called well, general form of line in R2. So let me just put general form of line in R3, sorry, in R3. So we have two normal vectors, which is A1, B1, and C1. We also have A2, B2, and C2. These one form general equation for planes, each one. Then they will have constant here, constant here. So while using the normal vectors in R3, we basically do find equations for the planes, and then put two of them together. that will give us a point. The intersection of those ones will give us a line. That's how we define the line using normal vectors. So very quick review now. We had two cases using direction vector, using normal vector. Each one had two forms in it, and you have to be able to go from one to the other one and transfer between these different forms.